So today I'm just basically going to do like a crash course on trigonometry. So I'm going to cover everything, but for the first hour, I'll cover like all the chapters and stuff. And the second, we'll go through like past year papers. Okay. So if everybody's ready, I can like start.
Can you like zoom in a bit more?
Okay. So yeah, trigonometry, the most basics is the three functions. So everybody needs to know that, of course. So you got the sin, cos, and tan. Like, yeah, it's pretty easy. All you gotta really imagine all the time is a triangle. Like whenever you're in exam, like just draw down a triangle. It'll help you a lot. So right here for IGCSE, there's like 6 trig functions we need to know. So the thing called tan, the easy one. And then for ATMAS, there's cosec, sec, and cot. But then these are pretty easy once you know how to do them. Like, okay, so there's a way, right? So cosec, sec, cot. Look at all their third letters. And so for cosec, the third letter is S. So it's actually the reciprocal of sine. And then for sec, it's the reciprocal of cos because the third letter is C. And for cot, it's actually the reciprocal of tan, but then like a reciprocal of tan, which is sin or cos, so it's just cosine. So yeah, that's how you remember it and how you have it in the exam. So whenever you calculate trigonometry, right, sometimes they won't give you the angle, but they give you the answer. And then with that, you just gotta like draw a triangle because sin cos tan is like sin an angle equals to something, and then cos an angle equals to something. So what they mean is in the triangle, it means like sin is opposite over hypotenuse. Then a lot of people recognize this with so, ka, and toi. So is like the two letters are like O and H. So it's like opposite over hypotenuse. Then ka is like AH, so adjacent over hypotenuse. And then toi is opposite over adjacent. So it's pretty easy to remember. Just gotta get that, like that, I don't know how to say it, the thing in your mind, like so katwa. You just keep saying in your head and then you get it. So I believe a lot of people, like you guys don't struggle with this, right? So this is pretty easy. So after that, these are the exact values. So these are the values for like specific angle numbers, and then you need to memorize like what's the outcome. So I mean, there's not really anything to talk about this. You just gotta memorize like what is, but there's like tips to memorize like what each number represents. So for sin and cos, right, they're actually like equal. They're a bit different, but they're about the same. So you can see the pattern is if you want to memorize, but yeah, but you probably need to if you want to score like an A in maths or something. So for sine 30 is 1/2. But so the opposite of that for cos, right? It's like cos 60 is 1/2. You can kind of see the pattern where cos 30 is equals to sine 60, and then sine 30 is equals to cos 30. And because of that, it's like sine 45 and cos 45 equals the same thing. And then yeah, everything is just different. It's like sine 0 is 0, but cos 0 is 1. And then that applies for 90 as well. It's like sine 90 is 1, cos 90 is 0. So I think you just need to memorize like for like sine, like the arrangement from 0 to 90. And then if you want to memorize cos, you just flip it around. So yeah. So you just got to memorize. Nothing you can do about it, but it'll help you, I guess. So for 10, it's a bit different. You just got to memorize it, of course. But then you got to know that 1090 is it's not a number. They literally can't find it. It's like indefined, something the word is. And then so you just got to memorize 1000, 1030, 1 over square root 3, 1045, 1, and 1060 square root 3. But these are easy, so I'm just going to skip past this in a while. So yeah. So what can't you draw the triangles out to get the value? Yeah, but like you shouldn't like waste your time like drawing it out when you can just memorize it, because like you should like leave your time for other questions. Someone asked what website is that? I made this myself. So yeah. So after this is like a more important part. This is where more people mess up. It's actually what the graph looks like, because some people might be confused or whatever. So sine x is kind of like a semicircle and then a semicircle at the bottom. But what you got to memorize is like, after like sine 180, like it's just a negative. So it's basically like an opposite of each other. So yeah, it's like the first half of the sine graph is positive and then the second half is negative. But for cos, it's different since it starts at 1, right? But it's about the same with sine. It's like you start at 1 and then 180 it will like go into another direction and then like start going up a positive gradient again. You guys are asking, can we get the site? So at the end, I'll ask for your feedback, and if there's enough people interested, I'll think about releasing the notes. Yeah. But okay, so the hard graph is tan, because people get confused, like where do I put it, where do I like write it or whatever. But you just got, it's like exponential. It just starts at somewhere and then it goes all the way up to like infinite, basically. So all you can see here that 90 and 270, these are called asymptotes. It's a place where like the graph never truly reaches it. What website is this? I made this myself. So yeah. So but the only thing different is 10x. It's actually the period is 180. So it isn't until all the way to 360. So it's actually just one going up and one going down. So that's just one period itself. And one thing about tan is there's no amplitude, because it just goes up until like infinite. So there's no amplitude for it. So one frequent question where you can score easy marks, that's a 5-mark question. Like later you can see the party questions, like the 5-mark questions. These always come out. And so basically, you should definitely like get this down so you can get the 5-mark. So there's 4 important things. Vertical stretch, so it's just amplitude. So it's just like how high, what's the peak of what the graph reaches and stuff. And for B, it's the period, especially the stretch, is like how many frequency of the graph there is. Like if you know physics, you should be all right with this. But yeah, period just means frequencies. Like, but I'll show you guys later, like with this graph, then you can really like understand it. So C is phase shift. So you can like move the graph from like left to right. So yeah, that's basically it. And then D is just vertical, so up and down. So if you guys, I feel like it's easier to visualize when you have it. So let's say amplitude. You guys want to see what a tree amplitude is? See, look, the graph reaches like a higher point for both positive and negative. So yeah. Then for period, it's just a multiple graphs in a row. So let's say the period is 4. You can see there are 4 like up and down, like slides. So okay, wait, let me restart this. And then for phase shift, so left and right, you can kind of see it. Like it doesn't really go left and right, but then the point where it used to be like switches places. Like some questions will have like this like plus 90 in it, but for that you need to like switch the domain, but that's for later. So yeah, vertical shift is up and down. The graph's completely the same, it's just either up or down. So I can show you guys this for cos and tan, but you guys can tell me what you guys want to specifically see. So I'm gonna skip past cos because like it's way too easy. Phase shift. Okay. Phase shift. Phase shift is like changing the angle inside of the sine function. So if I increase it, right, you can see that the point where it used to be on like 180 is like moved to the left when it's plus. And then, so that's basically the same for negative. For negative, the point where it used to be moved to the right. So yeah, um, it's basically moving the graph, but it's exactly the same. The amplitude is all the same. It's just moving the graph left or right. It's just the more confusing thing is like when they add everything together, like let's say the amplitude is 2, and then the period is 3, and then the phase shift is like 90, and then the vertical shift is 1. This is like what confused you, but you just got to break everything down like one by one, and then you really get it. Like, MS is just like, they just added more steps basically. But if you're like confident at the base stuff, you should be fine. So someone asked, how does amplitude for tan work? So amplitude for tan, for us, we really don't need to know anything, because since the graph is going to like, it's exponential, it's like goes up until like infinite something, and then the asymptote is 90. Amplitude just means that it just has a steeper gradient, but it doesn't really change anything. It doesn't really like change how the graph never reaches like that point. Like it never reaches the 90-degree point. And yeah, period also affects for tan graph. It's just more of these like squiggly lines. And if you want to see like how a different amplitude change, like increased amplitude, see it's just a steeper gradient, but it doesn't really change anything. The asymptote is still 90, and that's nothing different lah. Then phase shift is just also the tan graph moving left, moving right. Basically the same. It matters. It all these like changes every type of graph. So it's okay. So if that's okay, I'll move on. If anybody else have any questions about the graph, because like the graph does like provide a lot of marks. Okay. So next. So a lot of people actually like wonder what is radians. Radians is just another measurement of degrees. Honestly, it's like how to measure angles, right? It's either in degrees or radians. So these are basically formulas on how to switch degrees to radians and radians to degree. Like you don't have to think much about it. Like as long if you think they're both the same thing, like it's okay. Like of course you can memorize these conversions, but you don't really need to if you have like if you know how to switch it like well. So like this one degree to radians. So it's like if your degree is 360, right? So 360 times pi over 180. So the degree in radians is 2 pi. So you can see they mean the same thing. So don't confuse yourself about this when you see like pi over something. It's just another angle. Just always put it into the function anyway. So there's like one tip here, right? A lot of people actually lose marks because they calculate something with the uh, wrong symbol. Like it's like the question asks for answers in radians, but you count it in degrees. Like totally different. And also, don't be afraid. Like when your calculator comes out, it's like 2.3 or something like that. Like that's okay. As long as you can see the top left of your calculator, it says R right there, then it's okay. So here's like some quick tips about how to switch it. So just gotta make sure every time. Like once you see a trigger question, check it. Yeah. But this like more of your you need to memorize, you need to know it yourself. Lah. So okay, actually these are actually for math, the sine rule, cosine rule, area of triangle. But some questions in math need like really strong foundation on sine rule, cosine rule, and area of triangle. So these are also really important. So you can see at the bottom here, you know like which rule to use whenever what question there is. So for sine, it's given like a side and then an opposite angle. So let's say you got side A, and then you got the opposite angle of uh of the side. So it's basically like when you have like three things, right? You just want to find the length of the angle opposite of one of the things. Okay, it's a bit hard to show, but I can show you guys here. Let's say, so let's say this is angle A and then side A. So you use sine rule when you want to find this length, which is side B. So you can just put like sine A over A sine B over B. So you find this. But yeah, you guys should have learned this in math. You don't need to memorize it because I think it's in the formula sheet in front. So for all these, you need it's all, the formula is all in front. But for me, like, if you want to go fast, you don't want to like lose time, you should memorize it. So right here it says ambiguous case. That means like if there's like two slides and then like an angle that really like you don't really know where it is. They might give you like uh two places where the side where the length could be, because it's like ambiguous. So not sure how to say, but it's like give it. So no, okay, wait. I just mean like how do I say? When you given two sides, right? And then like you don't have an angle, like you might get like two different like angles or like something wrong. So you only really use sine rule when you have two lengths and one angle, or two angles and one length. So yeah, that's like a very specific case. But then for cosine, right, it's the only way where you have three sides, and then you need to find an angle. That's how you find. You have three sides, and then you can find an angle. And then with the angle, you can use sine rule to find the other angle. So yeah, they're like complementary. They work together. And then for the area of triangle, it's just you finding the area of the triangle. It's just A and B is the length between the angle. So I'll show you guys here. So this needs to be A, this needs to be B, and then this angle is C. That's what the equation means. But yeah, this is math stuff, so I expect all of you guys should be good in this. So this is, okay, I'm moving on to identities. So identity is like a big part of maths. Like, okay, identities, wait, I think it's in front of the formula sheet, but then it's good for you to memorize so you don't have to like flip it back and forth every time when you have a trigger question. But of course, like if you have no time, also can lah. Like you don't need to memorize it. So here it's just deriving like how they get each identity. You don't even know this. It's just a fun fact. But yeah, it's just like how they prove each identity, why they exist. So these are the workings for it. So these are the three main identities of maths for IGCSE right now. Like that's the only ones that we need commonly use. So if you don't want to memorize this, these are like some key arrangement to memorize, because like usually the questions will come out like sine square and then like a cos, and then you have to change that sine square to 1 minus cos square, so you can have both cos square and cos, so you can have a quadratic equation, and then in return you can find the answer. So yeah, I'll say that these are good to memorize, but if you're strong enough, you can already like identify it from these identities at the start. But it's okay. Like if you're unconfident in trigonometry, so you should memorize it. So identities is pretty straightforward. It's either you get the answer, or you might like go a bit too far away and never get the answer. So identities is just you gotta practice a lot, like exchanging stuff, like exchanging sine square to cos square, sec square into tan square. So yeah, identities is mostly practice. But next, solving equation. This is you need more attention to detail because this is a bit more complicated, I would say. So it's called a CAS diagram, but I usually call it ASTC. So how you remember it is it's like a circle, And then, so since a circle, what's a circle like? It's like a clock. A clock, right? So I memorize it as a 0. 0 is like the right side. The right side. So like, okay, that's north, south, east, west, right? And then it's like north is at the top, south is at the bottom, west is on the right, east is on the right. Wait, east is on the right, but left is west. But it's okay. You just gotta memorize it always starts at the east. And then this clock goes anti-clockwise. Like goes 0, 90, 180, 270, 360. That this goes into, this is an infinite loop unless you give it a domain, which is what usually what the question does. So that's why there's multiple answers. So if either you want to memorize path or ASTC, it's okay, as long as you can. You always need to write it down whenever you solve a trig equation. It's really helpful. So just want to remember A. A is all positive. S only sign positive. T only sign positive. And then yeah, cos only positive. So ASTC, ASTC, ASTC. So that's why when you for trig equation, there's multiple answers. Like technically, if you don't give it a domain, there are infinite answers. So yeah. So this is like a really simple method where you like keep everything, where you find like a principal value, and then you use that value to find all the other values. So the first method is isolated. So whatever equation it gives you, just make it so that like function equals to a number. Function equals to a number. Then with that, you can find your principal value. So yeah, this value is always between negative 90 and 90. Oh, and by the way, if you get a negative angle, it's just since a positive is anti-clockwise, right? So negative is clockwise. So, you know, yeah. Can you explain the cast method? So, yeah, that's a really long method, but but you isolate it and then you find the principal value. Then with this principal value, you always should draw this ASTC down. And then what I like to do is, let me show you. I draw like this. Okay, the principal value, let's say it's a positive principal value. This is the principal value here. So this is actually like sine x equals k. And then x equals to sine k. So this actually, wait, let me write it as principal value. Principal value equals sine, inverse sine of k. So this is the inverse value. And then you can see k is positive, right? And so we got to think A, S, T, C. So what are the places where the quadrant is positive, that sign? So you may think like, wait, why can't I plot the thing here? Or should I plot it like here? So this is one thing to note, is you always plot your like angle basically on the x-axis. X-axis. Yeah. So that means your angle will be like here. So this is your principal value. But then to count your final angle, you always start at the A. So you go anti-clockwise, boom, here. So this is your other angle, which is, and you know that this is 180. So this actually, the other answer is just 180 minus principal value. So yeah, so for cast, there's multiple answers always. You just got to think about it. Just try to find all the answers until you think there isn't anymore. And then, oh, this is a pretty hard question. This is a, like, in the domain, it's like, it's not just X, there's like something different. So this one, you should expand the domain first. And then it's easier to solve. Because sometimes you get an answer that you don't know if it's whether in the domain. So you can get the answer and then compare it back to the domain, whether it's in the domain or not, then you know. So this is basically easy cheat sheet. If you don't want to think about it much, you can memorize it of how to find the second angle. So for sine, just now I just draw 180 minus principal. Cos is 360 minus principal, because if an angle is plotted at I call it like the x-axis where there's like 0. This is the principal value. You start at 0, so it goes. Okay, I don't know why my ink is turning black, but if you guys can get it, yeah. This is like the angle that you're measuring. So it's 360 minus the principal value itself. And then for tan, it's 180 plus, because tan is the, okay, I'm just not sure it again. Tan is this one. But the principal value is here, because it's always plotted on the x-axis, and x-axis is always horizontal. If you don't memorize it as x-axis, just memorize, you always plot it on a horizontal line. So yeah, so since you start at A again, so it's 180 plus this principal value here. So that's how you get all these finding the second angle. But usually the questions might have more than 2 answers. So you actually have to just check again now. So here's an example, like sine x equals square root 3 over 2. So this is the domain, so it's between 0 and 360. So the principal value here is 60. And then since this is sine, we go back up here, A, S, T, T. So sine is the second quadrant. So since the answer is positive, so it's A and S, that's the answer. So, and then the first solution is 60, the principal value itself, that's also an answer. And then the second angle is, you can use this formula, 180 minus 60, 120. But I wouldn't advise like memorizing like a formula to like answer a question. I would suggest like drawing the ASTC out and then like doing it. So that's about it for Trigo. Okay, I covered it quite fast, 30 minutes. So these are practice questions from easy to hard. Do you guys what do you guys prefer? Do you guys prefer doing these easy to medium to hard questions, or you guys or I go through these and then you guys can do the hard past year papers, like, or the past year papers itself? Hi, Kerr. Oh, someone asked, what about reverse quadrant? What do you mean by that? Oh, like the domain is in the negative. Okay. So the domain in the negative, right? So they account for the negative angles itself. And negative angles are like just the backwards. So instead of starting at 0, like that. How you would, oh, fuck. Oh, my bad. So how you would plot a negative angle is, instead of going this way, the angle goes this way. So you would plot it something like this. But then this is also a principal value itself. So it's okay if you have so it depends on what your final answer is, like this K. It depends if it's positive or negative. Then in your ASTC itself, you know where to plot it. So if, okay, let's say the angle is negative, right? But it's in the cos quadrant. So this like a cos answer, like this x. So the other place where x can be is just a itself, because this is positive. But then if it's a negative k, it will be, the angles will be here and here. So, but you have to count those angles from like here and like here. But then one thing is though, if the domain is negative, right, you can also like count the angles here. Like you start from the A and then like count all the way here. But these are pretty rare, but you can like try, you can also find it and see if it fits to the domain. So if it's like negative, right? If it's like cos, the negative one will be in sine and tan. And then it's the positive A and C. So it's opposites of each other. So these are practice questions. So do you guys want to do these? I just go through these easy questions and then you guys want to do the hard ones instead. Can we do one medium, one hard? Okay, and then I'll go through the rest. Okay, so this is an easy question. So this one, like sine angle equals 305 and angle is acute. So find the exact value of cos and tan. So this is the basics. This is SOHCAHTOA. And then I have the answers here, but I'll show you the working. So wait, I have it up here. So sine angle equals 305 and angle is acute. So you remember that, so right? So O and H is opposite over hypotenuse. So 3/5 is actually opposite over hypotenuse. And then with this, right, you can find ka and toa. So ka is adjacent over hypotenuse and toa is opposite over adjacent. And you're thinking like, wait, how do I find adjacent? Just draw the triangle. So that's your angle. And so opposite is here. So opposite the angle. Hypotenuse is the longest one, which is and also opposite of the 90-degree angle. Because remember, this is always a right angle triangle. So quick math, it's 4. So ka is actually adjacent. So adjacent is 4. So ka is 4/5. So for cos equals 4/5. Then tan is opposite over adjacent, which is 3/4, which are the answers here. So next question. So you can see this is a solving equation. This is pretty easy. So let me show you the answer. It's 120 and 240. Go somewhere here. So first you want to find the principal value, right? Since it's already like done for you. So x equals to cos -1/2. Then this is, I'm not sure what this is. Let me pull out my cos. Cos -1/2. So this is the principal angle is 120. So you can see the answer is negative here. So let's draw the ASTC. Here. So so actually this is in 120, right? Like this angle is 120 here. This 120. So technically this is, I'm wrong. This is not the principal value. So how to find the principal value for this is this angle right here. So which is 180 minus 60 equals, minus 130 equals 60. 120 equals 60. So the principal value is 60. So since the answer for this cos is negative, right? So the only where it's at is t. So let me draw here. So this is principal value, so which is 60. So the other angle would be from A come all the way to here. So A to S is 180 already. So the second answer is 180 plus 60 equals 240. My bad, my handwriting's a bit ugly. Not used to putting on the mouse. So the answer are 120 and 240. Yep. So this one, amplitude and period. So period is the one inside of the box, and amplitude is usually the left side of the function. So we can just see that amplitude is 4. But then for period, so a normal period for sine is 360, right? Sine and cos is 360. And then for tan is 180. So 3x equals 360 and x equals 120. So amplitude 4 and period is 120. Someone asked, is the principal value always an acute angle? Yeah, but it can be negative also. But I don't know if a negative angle is an acute angle. So I'll let you guys do one of the medium questions. Can you guys do the identity one? Second one. So it's 4 marks, but I guess I'll give 4 to 5 minutes for it. So actually proving the identity. Actually that's too easy. Can you guys do the first one? 2 cos squared minus cos minus 1 equals 0. So it's a quadratic, kind of like that. So I'll let you guys figure out. Tell me when you guys find the answer, drop the answers in the chat. I'll confirm if it's right after 4 minutes. 'Which question we doing? We are doing the first medium question. So 2 cos square x minus cos x minus 1 equals 0. So 4 minutes for this question. Zero, 360, 120, 240. Okay. So 2 more minutes until I show the answer. Or if there's enough answers, I'll just show it because it's pretty easy. So I think there's enough answers now. Throw the answers. Okay, so it's quadratic. So you factorize it out to cos x plus 1, cos x minus 1 equals 0. And then with this, you have two answers. So that means you solve both answers. So for cos x equals negative 1 over 2, that's 120, 240. Cos x equals 1, that's 0 and 360. What are we doing? We're doing a crash course on trigonometry. So most of y'all got this correct. So, okay, this is an identity question. So this is a part where you can like drift off and get like a random answers where your left-hand side is not equal to your right-hand side. So I'm sure you got the working. So let's expand like the stuff that we know what it is. So sec x, the third letter is e, so it's the reciprocal of cos. So it's 1 over cos x minus cos x. And then you also expand tan x itself, so it's sin over cos. And then from then, you combine 1 over cos x minus cos x. To do that, you just change cos x into cos square x over cos x. So, and then you combine them, 1 minus cos square x over cos x divided by tan x, which is sin over cos. And then with that, you can simplify it. You can get rid of both cos, which is left with sin x. And then, 1 minus cos square is equal to sin square. So sin square minus sin divided by sin equals to sin. So that's just the working. You prove left-hand side equals to right-hand side. So yeah, that's all. Next question. Tan x equals 2. Find the exact value of sec square x and hence cos square x. So let me show the working. So let's expand what sec square is. Sec square is 1 plus tan square. And then tan is 2. So 2 square is 4. So 1 plus 4 equals 5. So this is pretty easy. Cos square equals to 1 over sec square because cos is 1 over sec square because the reciprocal of sec is cos. And yeah, and that's because if you memorize it, like the identity, you can like find this out pretty easy. So 1 over sec square, and just now you already find what sec square is, right? So you just sub it in, so 1 over 5. So these are medium questions, these are pretty easy. So I'll just like quickly go for the harder one. So cosec square minus cot square x minus 4 equals 0. So I want you guys to solve the first one. Yeah. So cosec square minus cot 2 cot square minus 2 cot minus 4 equals 0. Uh, this is 5 marks. I'll give 5 to 6 minutes like that. So drop your answers when you're done. And remember, this square is something like a quadratic. And then since you're solving trig, there's going to be multiple answers. So check all your quadrants when you draw your ASPC out. Okay, so about 2 minutes left. For answers and angles, right? Try to keep your answers to 1 dp. So like, yeah, round it off to 1 dp for both radians and degree. MT9. Same thing as just now. Only 1 dp. So 1 decimal point for answers in angles and radians. And for anything else, it's 3SF. Okay, so that's about time. Go through. Okay, wait, let me increase the font of answer. So this is about this like mixing identities and also like solving an equation. So first thing first, cosec and cot, they're both different, so we want to change them to the same thing. So with the identity, we change cosec square equals to 1 plus cot square. So once you combine that, it should be quite straightforward. Like cot square minus 2 cot minus 3 equals 0. Factorize it, then you can get each answer for each function. But don't like you gotta be very like cot x, you gotta switch it to 1 over tan. So like what the working here did is they just like skip past that step and they remove the 1 over by doing the same exact thing to the other side. So it's just like removing it. So this is just like a quick way lah, if you know what cot x stands for. So with that, tan x equals 1 over 3. So it's positive. So the quadrants is A and T. So you can find those, yeah, pretty easily. I see basically all of you got it. Then for cot x equals -1. So 1 over -1 is still -1. So tan x equals -1. So another 2 answers. But this is negative, so the answers will be in quadrants S and C. Okay, so next question. So this is another identities question. You just got to swap around and stuff. So first thing first, left hand side. Okay, to switch it, this seemed like it changed a lot, but actually it didn't that much. All it did is they make both the fractions the base the same. So for the left one, it's like 1 minus sine x, right? So they times that by 1 plus sine x. And for the right side, they did 1 plus sine x times 1 minus sine x. So this way they can have the same base, so they can combine them together, basically. So combine together 1 plus sine x plus 1 minus sine x. So after you minus that, so it's just 2 over 1 minus sine squared. Want to expand everything. So that's pretty easy. 2 over 1 minus n squared equals 2 over cos square. And then, yeah, that is sec square because 1 over cos is a sec. And then since it's just square, it's just the same thing. So that's how you prove left-hand side equals the right-hand side. So one thing is like for identities, you just try to change stuff that you know into something or either like combine fractions together. So yeah, pretty straightforward. Like if you go off and like you can change whatever, then you might get it wrong lah. But what can you do about it? So this is another solving trigo equation, but this is a bit more complicated because you can see this one, the angle inside, it's different. It's not just x anymore. So based on the tip earlier, what you're supposed to do is change the domain first. And how do you do that? Is just substitute this number inside into the domain. So 2x minus 30. So if we put that into the domain, 2 times 0 minus 30 equals to negative 30. And then 2 times 360 minus 30 equals to negative 30 u 690. So this is your new domain. So you need to find all the answers that fit into this domain itself. Hey, your final answer are based off the domain, right? Yeah, you can check it back to your first domain. So after that, you just do 2 over 3, and then you can sign, and then you find the principal value. But you don't need to care about 2x minus 3. You can just treat it as x itself because you already changed it by changing the domain itself. So that's already done. You can ignore it. The task is done. So you have one principal value. Okay, and then this is pretty complicated, but let me show you how they get each and every answer for this. So, so we know that the principal angle is inverse sine of 203. So the angle is 41.8. So 41.8. So this answer is positive because it's 2 over 3, right? It's positive. So let's draw this up. The domain is negative 30 is 690, and then there's A, S, B, C. So principal angle would be here, 41.8. And this is already one of the answers itself. So with this answer, right, you can put it back into what you did. Like you find this already, right? Since you find this, you put it back into what you changed it as. So 2 over, it's like you replaced it earlier. Now you just like put it back in. So your first answer would be, let's check the first one, 2148. You can see the answer is 35.9. So that's our first answer. So let's see our second answer is 41.8. It's positive. So let's draw the second one. 41.8. So boom, quick math is 138.2. And then once you sub it back into what you changed it earlier, same as the first one, you get your second answer, 84.1. Then since you see it's 690, so you can like do one rotation and another. So this is like one rotation and then the extra one. So it's the third angle will be 360 plus 41.8, 41.8, which is one of the answers here, 401.8. Then once you put it into the domain again, get 215.9. Okay, the last one is just another one here. So this is 540 actually once because 180 plus 361 rotation is another rotation. So 540. So 540 minus 41.8 is 498.2. 498.2. Change it all. 264.1. So these are all the answers. the inside 360. So, so these are four answers. Like this negative 30, it doesn't make a difference because if like you put negative 30 here, like this answer should be negative since it's in the cost quadrant, but our answer is positive. The 203 is positive, so it can't be that. So these are just the four answers you can find. So when the domain is like larger, they usually have four answers, sometimes five if they have an extra negative answer somewhere. So there's more answers, but it's a compounded domain basically. So this is all past year paper questions. I want you guys to try every one of these questions because I have a lot of time, like 1 hour. So everybody should like try each question and then like, yeah, that's how we improve. So yeah, important thing, always draw the ASTC or CAS diagram. Then there's just quick reference in case you get lost. So first question, cosec square minus cot x equals 3. So this one's also pretty easy, but it does come out exam. So just gotta solve it basically. So 5 mark question. 5 mark question, 5-6 minutes like that. Six, two, six. Okay. Someone already got an answer. Okay, I'll just stop waiting for now. And I'll go through it. Most of you guys got the same answer, so I'm assuming it's just correct. So let's see. Okay. So the same like just now. Substitute cosec square, 1 plus cot square. And then you combine them. 1 plus cot square minus cot x. And then you bring the 3 over. And then you get a quadratic equation. But if you're confused, you can kind of substitute the cot x out for like y perhaps. Then you can find it easier. But this is okay if you know what you're doing. So let's see. Yeah, most got this correct. It's pretty easy. Cot x equals 2, tan x equals 1 over 2. So same as ASTC again. Guess I'll just show it. So for this one. So since it's cot x, it's tan x basically. So finance answer is tan x equals 1 over 2. Tan x equals -1. So one is positive, one is negative. So technically we're covering all quadrants today. But for tan x equals 1 over 2, the principal value here is 26.6. So with that, t is here. We can find our other value 20.6 here. So that's how we find 26.6. Then the next one, which is 180 plus 20.6 equals to 206.6. Yeah, wait, I wrote here wrongly. 206.6. So that's the first one. Oh, if you want, if it's two different functions, if you don't want to confuse yourself, you can just draw another ASTC in your paper. Not, it doesn't take that much time. So -1. So the thing here is 135. So 135. And then it's in the S quadrant because the answer is -1, which is negative. So it's in a negative quadrant, which is S and C. So the other one will be C. But with that, we need to find the principal value first, which is this thing, which is always plotted on the horizontal line, which is 180 minus 135, so 45. Then let's plot C. C is the only other -1. Then plot the horizontal line again, 45 degree. So boom, or which is equals to 360 minus 45 equals 315. So yeah, that's how you get that answer too. So first party paper done. Okay, this one is a bit longer and the domain is different. So yeah, this will be a bit more challenging. But once you know the basics, you just gotta be careful and you get it right. So this one could be like multiple answers, but it doesn't mean it's be like in 2 or 4. It might be 3. So you just gotta be careful. And also the domain is different. You can see the 2x plus 45. So I suggest you change that first. Oh yeah, so there's 6 marks. So I'll give 6 to 7 minutes. But yeah, I'll see how quick you guys are done with it. How long? 6 to 7. I bet. I'll show the cast diagram. Time's up. So I'll show the working. You guys got all the same answers, so you guys should be fine. So first off, isolate it. So that's the first step. Assign something to skirt 302. And then after that, we expand the domain. So sub it in 2x plus 45 for both negative 180 and 180. And get negative 315 and 405. So actually, if you memorize right, skirt 302 is actually sine 60. But yeah, it's one of the values in the table. So since sine is positive, it's quadrant 1, quadrant 2. So 60 and 120. Wait, what? You got different answers. Yeah, am I tripping? We're doing question 2, right? Yeah. You minus. Oh wait, yeah. Okay, wait. Let me. Yeah, my bad. I'm a bit slow right now, but I'll just show here each part. So my bad for that confusion. I confused myself. So principal value 60. And then since they're positive and negative, let's list the negative out first. So since the answer is positive, so here 60. So for positive answers is 60 and 120. So and also let's check. The expanded domain is 405, right? 360 plus 60 equals to 420. So since 420 is more than 405, so this answer is like rejected for like a full circle plus the principal value again. So you check that. So it's good to check that. So in case if like the domain is like 425, then you have 5 answers instead. So next is negative. And then since negative is anti-clockwise, so we start here. But then as long as it ends at a positive quadrant, it's also a negative angle can also give a positive answer. So these are the two. So 180 plus 60, so it's 240, negative 240. And negative 360 plus 60 equals negative 300. So we have these 4 answers. We convert back into the domain. So I don't think I need to explain that, but yeah, for the numbers 60, 120, negative 300, negative 240. All these minus 45 divided by 2, you get negative 172.5, negative 142.5, 7.5, 37.5. Check again. This is between negative 180 and 180 because this is the normal domain. So all of these fits. So four answers, 4 questions. So yeah, I guess you guys are all pros because you guys are all getting this right. So this is usually like a good past year paper question. So yeah, and it's pretty easy to solve. Oh shit, my bad. I accidentally flashed the answers. But this one's a bit different. The answer needs to be in radians. So let's check back on my tip here. This is how you change your calculator mode into radians because just now the domain was between 0 and 2 pi. And if you know 2 pi is 316 degrees. But yeah, change your mode into R, which is in radian mode. To your angle. So when you inverse sine the answer, you get in radians instead of degree. Once you've done that, then you continue doing this question like normal. It's like a lot of people actually like they do this correctly, but their answers in degree, so they get this wrong. So this question 5 marks, so 5 to 6 minutes like that. If anybody gets stuck in like the middle of it, then you like explain where you got stuck at, and I'll like explain it when the time's over. Uh, you can't hear anything because I'm just giving time for them to try the questions and I'll explain it. Yeah. Yeah. I'm just doing a crash course on trigonometry for IGCSE Maths for CAIE Cambridge. Yeah. We are currently doing the third question. So this is IGCSE. Yeah, it's just Maths. That gonna be a normal math session. Tomorrow a person is gonna cover both math and maths past year paper. I'm not sure what they're gonna do, but yeah, there are gonna be some math inside the time. You can check your local time in the study session there. 1.0330454. Why not? Yeah. Okay. The answers are in, so I'll go through it now. So first things first, substitute 6 squared with 1 plus 10 squared. Another identity. These are really common, basically identity plus quadratic. So with that, you can substitute. So it's actually there's a 3 in front. So you got 3 times 1 plus 10 square. It's like some people times the 10 square, but they don't times the 3. So you got like take note of that. Like write it in brackets so you don't miss out. And then after that, once you do everything, your final answer will be 3 tan square minus 2 tan minus 5. So this is another quadratic. So with the quadratic, factorize it, equals 0. You get the 2 answers. So these 2 answers, they're both one positive, one negative. I'll show you guys the ASTC again. So this is the part where most people mess up. So tan x equals to, write this down, tan x equals to 5 over 3. So this is in radians, right? In your answer, the first angle of inverse of 5 over 3 will be, let me check. Inverse tan of 5 is 1.03. So yep, this is the first answer and also the principal value, 1.03. So this is positive. So the other one will be t here. So by now you should know where t is without without writing it down. But of course you can write it down. Plot it on the horizontal line again, 1.03. And then instead, usually here is 180 degree, right? But now it's just pi. So the second answer will be pi plus 1.03, which is 4.172 if I'm not mistaken. So after that, tan x negative 1. So negative, I'm just going to draw a new one. Yes, you see, negative 1. So inverse of negative 1, negative 1 over 4. This is negative 1 over 4 pi. My bad. This is your principal value. It's what you work with. But then you see, this is not an answer because this is in the quadrant. Wait, this is the answer. Wait, let me check. What did I do? Negative 1. Yeah, negative pi over 4. But this is not answer. Oh, because it's not in the range. Of course, it's not in the domain. So your principal value, so A, S, E, C. So negative 1. So negative 1 over 4 pi. This is your principal value. So with that, you can find your value for the negative 1, which is here to here, which is 3 pi over 4. So that's one of your answer. So this negative is not one of the answer because the domain is 0 to 2 pi. So the second answer will be from A, and then you drag it all the way along to C here. So this is 2 pi minus 1 over 4, minus 1 over 4 pi, so 7 pi over 4. So that's how you get your answer, and your other two, 1.03, 4.17. So these are in radians, by the way, radian. Yeah. So the question covered. Okay, so now we are moving on to question 4. This is an easy question to get marks on. It's 6 marks, but I don't think you need 8 minutes. Wait, oh wait, no, that's then solve for fx equals to. Okay, I'll give you guys 8 minutes. So there's 2 steps in this question. It's like they combine 2 different things into one. So you find A, B, C, and then you also need to solve this. So that's first step, second step. So be sure to answer both steps so you don't miss out on anything. Yeah, seems you guys seem to get most of the questions right. So I guess you guys can get all you can all get A star now. Yeah. Question 4. Question 4. Hmm. Mm. About 4 minutes left. You should be doing your solve for fx equals 2 by now, or in the process of. Um, That's B. This is 3. 1, 2, 3, 4, 5. Okay. Answers. Okay, about like 2 minutes left now. If you're stuck on the questions, like better to skip past it and then come back again with the time you have left. If you do get stuck on a question in the exam. Oh, actually, I'm gonna explain now. There's still 6 more questions, and I only have 20 minutes left. So let's see. So finding A, B, C first. Amplitude is 3, so that's really easy. A is 3, and then period is 120. So Bx is like basically 360. Like one period of the sine graph is 360 degree. And then since one period is 120, right? So that means something bx equals to 360. So if, wait, no, bx equals to, wait, no, it's supposed to be 360, but then now it's 120. So that means they changed the b. So how they did that is the 360 divided by 120 equals to 3. Yeah, my bad, I confused myself just now. But yeah, you're supposed to take the original 360 divide by the what the period changed into, which is 120. So for the minimum value equals to -1. So since the sine graph has one positive and as a maximum value and a minimum value, and usually the maximum and minimum value is equal to the amplitude. So it should be -3, but now it's -1. And then that means we know that the C, like the vertical shift, that means it plus 2 because the -3 plus 2 equals to -1. So that's how we find C equals to 2. So this is our final function, 3 sine x bracket 3x bracket plus 2. So we sub this in, this to equals 2. Minus 2. So 3 sine 3x equals 0. So that just means sine 3x equals 0. And then after that, we need to switch the domain first because the is more than 1 inside. So 3 times 0 equals 0. 3 times 240, up here it says that 240 equals to 720. So you have these. And then since the sine 0 is 0. You know, sine 0 is 180, my bad. But it's also 0. Because if you see the graph here, it starts with 0 and then 180. But of course you can, if you don't memorize it, you can just like put it into the calculator and then you can see it's 180 and 0. So wait, let me show the ASTC for this one. So, yeah. So, you know, it's just 0. Here's 0. That's just 180. So there's actually no, what's that word? The value. That's the value of the angle. Usually that we have an angle, the value, right? So there's nothing. It's just 0. So it's 0, 180, and then come back here again, 360, and then come back here again, 540, then 720. We choose this 5 because these 5 fit into the domain of our expanded domain. Okay, so 3x, like what the answer says, 3x equals to all 5 of this domain, all 5 of these angles. That's what I meant. So you got to divide by 3 to get the actual one because this one was expanded, right? So you got like sub it back in. So 0 divided by 3 is 0, 60, 120, yeah, and then so on and so forth. 180, 240. So yeah, this is an example of how a question can have 5 answers actually. And this is like, this is a multiple step question. First, they ask you to find, okay, my bad. I clicked on something just now. So, okay, it's back to this whiteboard already. So yeah, what I was saying earlier, this is a question with multiple steps. You find the amplitude period, you find the vertical shift. Then with that, they give you another equation, which is the solving trig equation. But this solving trig equation is quite easy once you expanded your domain. Yeah. Okay. So this proved the identity. You guys can write this down if you want to try, but I'm going to show a solution because there are multiple solutions. Like as long as your left hand side equals to your right hand side, it's okay. So there's no like one definite answer. So I'll just show like one quick way. So sec left hand side sec x plus 10x. We change those two. So sec x is the third letter c. So reciprocal of c, which is cos. So 1 over cos plus 10 is sin over cos. And then these are squared. Okay, then we combine both of the fractions because they have the same base. So 1 plus sin x bracket cos x. And then with this, we can square both the top and the bottom. Because if you square like a fraction, you square both the top and the bottom. So 1 plus sin x. So these are, this is what you get it. And then what they did is they replace cos squared equals 1 minus sin x bracket 1 plus sin x. Actually, this is like, say this pretty complicated way, but I think it's one of the fastest. So, so what I mentioned earlier, if you just got the correct answer, it's okay, but this is like a really fast way of how they like cut out the top and the bottom, simplify it. So that's how they prove left hand side equals right hand side. But it's a bit more complicated because it's like they change it into 1 minus sine square and then they factorize it again. So yeah, this is a bit more complicated way, but if you're good, you want to save time, this is what you do. So I explain this cos square equals to 1 minus sine square. And then 1 minus sine square can be factorized into 1 minus sine and 1 plus sine, which is here, bracket 1 minus sine, bracket 1 plus sine. So you substitute that in, simplify 1 plus sine x, 1 plus sine x. Boom, and then that's how you prove left hand side equals right hand side with 1 plus sine x divided by 1 minus sine x. Okay, so another identity question that's done. So this one's a bit different. These lines mean modulus. So whatever's inside this, they turn it from negative to positive. So if you did maths, you should know what modulus is. You learned it in functions. So I want to see you guys try this out. 5-6 minutes for this modulus question. Actually, after this, like the last question, I'll give you guys time to. I'll explain the rest. Most of it is kind of repetitive. So this modulus one's a bit different. So you guys take your time to do this, and then I'll just go on and explain the rest. So about 2 minutes left for this question. So the answer says give answers to 1 dp, by the way. Math during 8 is crazy. Yeah. I'm Chinese, so I don't really celebrate. So I have time right now. What's up, Abdullah? Yeah, good. It's just teaching class right now. Okay. Okay, thanks. Okay. It's time. So let's see. So there's actually 2 ways to do a modulus. First one is this way. You can see you do 3 sine x minus 1 equals 2 or 3 sine x minus 1 equals -2. But if you're like unconfident about this way, the other thing you can do is actually squaring both sides. But as you can see, if you square both sides, you're going to get like 9 sine square minus 6 sine x, something like that, which is like really big. So I recommend this way. This is way faster. But I can show you guys the other way. But let me go through this way first. So this one is just really easy. They move the -1 and then divide by 3. Then sine x equals to 1. So x equals to 90. So we know that in the graph of sine, like it goes 0 to 360, it actually only hits 1, 1. So for case 1, that's actually only one answer, x equals to 90. So for case 2, yeah, so sine x equals to -1/3. So we find a principal value, 19.47. Since the answer is negative, like what is this? Negative quadrants are quadrant 3 and 4, which is T and C. So T and C, 180 minus 19 plus 47, x equals 360 minus 19.4. I'll try to show the quadratic way right now because I think you can also do it that way. But let me try. So if we square both sides, so it's like if you forgot what modulus means, just square both sides if you can. Square, square. So boom, boom, that's 9 sine square minus 6 sine x plus 1 equals 4. So 9 sine square minus sine 6 sine x minus 3 equals 0. So divide by 3. 3 sine square minus 2 sine x minus 1 equals 0. 3 sine x plus 1 sine x minus 1. So actually, yeah, you can see it comes out the same answer. Sine x equals 1, sine x equals -1/3, which is these two answers right here. So there are both ways to approaching this question. And both ways also ASTC. The 90, you don't need to do ASTC because you know there's only one solution. Super value is 19.47. So since it's negative, it's quadrant T and C. So draw here, 19.47. So 180 plus 180 plus the angle. And then this one is T, like the formula 360 minus angle. So that's how you get all. But yeah, there are both ways if you want to solve the modules. So next one, actually I'm just going to go over the rest as much as I can once time's up. So y equals p plus q sine bracket rx. Maximum 7, minimum 1, period 180. So maximum 7, minimum 1. You can find the amplitude of this. Okay, 7 minus 1 is 6. And then you know the amplitude is like goes positive and negative. So it's two sides. So 7 minus 1 divided by 2, which is 3. So you can find the amplitude is 3. Because if you think about it, right, if the amplitude is 3, it goes up 3 and then goes down 3. So the difference is 6. So the amplitude is 3 for this one. When the difference is 6, the amplitude is 3. It's divide 2 of the difference. And then with the period, it's just 360 divided by 180 equals 2. And then you can see you want to find the plus p here. So this is the vertical shift. So since you find the amplitude, it should be -3, right? But then the minimum should be -3. But now the minimum is 1. So 1 minus -3 is 4. So the vertical shift is 4. Then state the range. Can find the range by substituting in the x. Oh wait, my bad. Range is just which is minimum and maximum point, so 1 to 7. Yeah, that's my bad. So that's just really simple. And then find the smallest positive x where y equals 4. So we sub in this, sub in y equals 4. So -4, so sine 2x equals 0. 2x with inverse sine of 0 is 0 and 180. So when you do that, then you get 2x equals to 0 and 180, because if you know the graph, it goes up, down, and then so 0 will be at the start and in the middle, so 0, 180. So once you divide by 2 is x equals 0 and 90, but they say smallest positive x. So x equals 90, because actually I'm not sure, but I don't know if 0 is considered positive or negative. But yeah, the answer is 90. Okay, the next one is trigonometry identity. This one is same. These are one solution, but there's multiple solutions can also. So same with fraction, you try to make the same base first. So same base, you times both sides the opposite of the number. So the left side 1 minus cos x. So you times that 1 plus cos x, and the right side is 1 plus cos x. You times 1 minus cos x. So you do that, combine them, 2 cos x equals bracket divided by 1 minus cos square. So you simplify that, 2 cos x equals sine square. And then that's the tricky part. You want to separate what each fraction means. So you can do here, they separate it 2 times cos over sine times 1 over sine. So you know cos over sine is the reciprocal of tan. So reciprocal of tan is cot. So substitute this to cot x. 1 over sine x is cosec, because third letter s, reciprocal of sine. So 2 times cot times cosec x equals this. If you're like stuck like in somewhere like 2 cos x divided by 2 sine square, actually you can like try to see like this answer, like how to say, you substitute this answer into something you know, and then you match it to where your current answer is, then it might help you into getting the right answer. So question 9. Cosec angle minus sine angle equals 3. So let's see. We can change cosec equals 1 over sine, which is what they did. And then you combine 1 over sine minus sine. together. uh, Type if you want it in the notes, whether you think you would pay for it or not. Like, just give me your feedback and I'll decide. Yeah. So that's about all about the session. Yeah, 2-hour session covering everything about trigonometry.